Okay, so again, we're going to start with what do we have that is given to us? What do we know? And what are we trying to find? All right, I'm going to go ahead and draw my square. Let's call this side length x. I'm going to need to know that the area in this case is x squared. And remember, this variable can be anything you want, but make sure you identify what it is. In this case, because I am using the variable x, and that is the side of the square, I'm going to say that dx over dt is equal to -1 meter per second. And I'm trying to find the rate of the area of the square. So that means I want to find the dA dt, the rate of the area over the change of time. And this is giving me a specific value. They're telling me that I want to do this when x is equal to 5 meters. So I'm going to go ahead and start with the known formula and take d dt of both sides. And that will leave me with dA over dt is equal to dx over dt. Then I take the variable and take the derivative of x squared, which gives me 2x. And that's all I need. I have everything else. I know that dx dt is equal to -1 meter per second. And I also know that x is equal to 5 meters. And this tells me that dA over dt is equal to -1 meter per second times 2 times 5 meters, or that gives me a -10 meters squared per second. We're going to, again, always start these the same way. I want to know what the given information is. I want to make a list of all of the known information that we have. And finally, what are we trying to find? And we're also going to draw a picture with this whenever possible. So our given information says that the side of a square decreases in length at a rate of 1 meter per second. So before I go through and do anything and write anything else down, I need to label my information, and I am going to label my square and give it sides. We'll call those S for both of them. So what I can say is I know that ds dt is going to equal -1 meters per second. And again, be careful with the verbiage here. It decreases at a rate of 1 meter per second, or the ds dt is -1 meter per second. You don't want to say decrease and negative. All right, what do I know? Well, I know that I have the area of a square. That's the side squared. And what are we trying to find? We're trying to find the rate of change of the... And that actually needs this one to draw on a diagonal, and we're going to go ahead and call that diagonal L. So I'm going to go ahead and add to that I know that s squared plus s squared is equal to L squared, or that 2s squared is equal to L squared. Because what we are trying to find here is the rate of change over the lengths over time. So I am looking for dl over dt. So let's go ahead and use this formula that we have. We're going to take the derivative with respect to time for both of them, and that will leave me with ds over dt of 4s is equal to dl over dt of 2l. Again, the implicit differentiation, we're taking the derivative of s with respect to time, that's my ds dt, and then the derivative of 2s squared, which is where I get the 4s from. I take the derivative of L with respect to time, which is my dl dt, and then the derivative of L squared, which gives me my 2L. Now, as I'm looking at this, what do I know and what do I still need to find? Well, I know that ds dt is equal to -1 meter per second, so I can substitute in for that. So we want to go ahead and find for dl dt. We're going to do that by dividing both sides by 2L. So now I'm left with dl over dt is equal to ds over dt, which again is just -1 meters per second, times 4, and this is my variable s, my side length. So let's write this as seconds so I don't get confused with that. And this is all being divided by 2L. Now, we don't have any lengths or anything to put in here, but what we do know is coming back up to the very beginning, and we used this trick before. I know that 2s squared is equal to L squared, so let's go ahead and make a substitution inside there. You cannot leave it like this. Rationalize that denominator, and dl dt is equal to -1 meters per second times 2 times the square root of 2, all divided by 2, or just -square root of 2 meters per second.